Hi guys, in this video I'm going to discuss about sliding window problem, the very first problem of sliding window, and this is most frequently asked questions in coding interviews. In the last video I already discussed like how can we identify the sliding window problems. Right? If we identify the sliding window problems, we can simply apply the sliding window approach. So we discussed already, right, 3 points. The first point, like, are we talking about array strings? Are we talking about substring or subsequences? Are we talking about window size? Whether it, it will be fixed or variable. So these three cases, if these three cases are being satisfied, then we can be sure like the problem can be solved using sliding window approach. So let us go through this problem like longest substring without repeating characters. Longest substring with distinct character. I can say in another way. Longest substring with distinct character. Longest substring without repeating characters. And this is most frequently asked question in coding interviews. Right. Let me draw the problem first over here. ABC, ABC, PP. Let's see if this problem is applicable for sliding window technique. Okay, so for that we need to check, are we talking about a string or array? So yes, we are talking about a string into this problem, right? String. We need to check, are we talking about substring or subsequence? So yes, we are talking about substring. Are we talking about window size? So if you look at the problem here, we do not have any fixed window size, okay, in the problem. Given a string is find the length of longest substring without repeating character. There is no fixed window length over here in this problem statement. So we have to, so window size is not available in the problem statement. This condition is fail. But first two condition is pass. If two condition is pass, then we can simply good to go with sliding window approach. Okay, so let's solve this problem with the help of sliding window approach. How can we actually apply sliding window technique over here? So to solve the problem using to apply the sliding window technique, so we have to maintain two pointers over here, I and j at initial position. Okay, and we have to find out the longest substring with distinct character. Longest substring. So we have to check till the distinct character. Okay, so to handle this scenario, we can use map, hash map. We can simply use hash map. This is the type of hash map. We will maintain each character into the hash map with their count. Okay, so if we're talking about I is equal to 0, j is equal to 0, what could be the data in map? A1. If j is equal to 1, then A, B. If j is equal to 2, then A, B, C. Right? So now let's go to the next step. J is equal to 3. So in this case, we have A, B, and again we have A. Right? 1. It should be actually update over here. Just for understanding, I'm writing o a over here. So we have to consider this a here. Okay. So since we got the it's a is not a distinct character. A is already exist um, into this map. So what could be the logic over here? So this is our variable window size. Okay. I now j at this point. Okay. J at this point. So k is nothing but variable window size. Okay, so window size will be calculated by j minus I plus 1. So what is the j value over here? 3. What is the I value? 0. What is k is equal to 4. Right. If we consider this a, then in that case, k is equal to 4. Right. So we have to iterate till end. Till end. Okay. So if window size for any sliding window approach, this will be the base condition. Window size is equal to maps. Okay, so here we will calculate the max length calculation. We'll get the max length and we will increment j plus over here. Okay, so till this step, like still C, we got the max length. And what is the max length over here? 3. This is the longest. ABC is the longest common substring with distinct character. But when A is comes up, so in that case, we have to refresh our window. The window will become this one, BCA. So we have to remove the element which are at ith positions. Okay, so this ith position element will be removed. Okay, so if window size, so here map size is still 3, but window size is greater than map size. In that case, we have to remove the ith element from the map. So we have to check if map dot size less than window size. So we have to remove the ith element until this condition is satisfied. So we will remove here calculation logic, remove ith element. Okay, remove ith element and will increment the I plus. me write the code in the Eclipse itself. Right. Let me create a package over here. So com dot beginner techies dot sliding window. This is not required. Okay. The class should be longest substring with distinct character. This is our class name. Okay, class name is okay. Right here I'm just taking the input abc abc bb. Right. Int max get longest substring gets longest substring length. Right. Okay, let me create this method. Right, we have to pass this string over here, input string. Add the parameter. Let me make it as input. Okay. Right. So let's think about the logic again. What we have draw over here. So we have this string. We have to maintain one map over here, right? Let us create a map. Okay. I'm creating a map to maintain the characters and the occurrences. Character occurrences. Sorry. This is my new patch map. Okay. Right. We have to maintain two pointers, I is equal to 0 and int j is equal to 0, right? And we have to maintain one max variable as well to return the result. Right, I'm just initialize with -1. Okay, I'm considering only the positive. Right, so we have to iterate till input dot length, right? Input dot length, right? Now we have to add our calculation logic over here. Calculation logic. What could be the calculation logic? First we have to add the sorry, it should not be map, it's a character occurrences map dot put. So what should be the key over here? So character should be the key. Input dot character j, and this should be input dot get, or sorry, not input, this should be getter default. What is the key we have? Input dot char j. And this should be either 0 or 1. Right. So if character is not exist in the map, then it will update with 1. If it is already exist, then it will increment the count. Okay, right. So we have added the we have added the character into the hash map, right? This steps. Now the next step is I'm writing the base condition over here. Base condition. Right. I'm writing the base condition. So what is the base condition? So base condition is map dot size, sorry, not map, it is character occurrences map dot size is equal to what? Window size. And what is the window size? Window size is j minus I plus 1. Okay, this one here initially. So this j is getting increase. Okay, so we are maintaining this window from I to j position. Okay. So here j minus I plus 1 will be the window size. Right. Now here we will calculate the max. We can simply use the max. Right. So max and j minus. So here we will compare with j minus I plus 1. So window size, right? So if we see like we have to find out the longest substring, and longest substring will be appear in the window size. Will always appear in the window size. Okay. So here we are comparing this. If character, if the map size is equal to window size, then we are just calculating the here calculating the result, right? And we are incrementing j plus plus, because we cannot just if we see here, so we have calculated till c now, right? We have calculated till c. This condition will be satisfied when j will reach to when j will reach at this point. Okay, c. So at this position we are calculating the max, and we have to increment. We need to check further. So that's why we have to increase the j plus plus. Now if this condition is not satisfied, like as is easily initially it was a only in the map, so this condition will definitely fail, right? If map dot size is less than j minus I plus 1. So in this case, we have to remove the ith window. We have to remove ith window, because condition is getting fail over here. So we have to remove the ith window. Character dot size character dot size less than j minus I plus 1 here, right? Put, so we have to remove ith window, right? So input dot caret I and character. So at this position we have to remove the element input dot caret I minus 1. We have to remove this, right? And we have to remove till our input dot caret I is equal to 0 until until it becomes 0. Okay, so in this case we have to remove, sorry, character options dot remove input dot caret I. We have to increment the I, right? And here we'll increase the j. So I think only, yeah, from here we can simply return max from the, right? So I think these two condition is enough, okay, because let us execute this. Let me print the output max, right? Let me run this program. Java dot, okay, exception in thread main java dot and pointer exceptions. What is the issue? Okay, so the problem is, okay, fine. Okay, so the problem is at this step, right? Sorry, here I did one mistake. Now this is fine. Let's execute it. Here we got 3. So the expected answer is 3. Let us add some more characters in this input. Okay, so C D E R F. Okay, let me run again. So now the output is 7. So what could be the expected output over here in this case? Initially the window size is, initially the longest substring. The first longest substring is ABC. Then second longest substring is again BCA, both are same. Then again longest substring is CAB, same, 3 size. Then again longest substring with unique character ABC, same. Again longest substring, no. So here there are some repeated characters, this size is 2 only. Okay, if we check from CB, then again if we see check from B, then again it is lower. If we check from B, C, D, E, R, F, T, yeah, so then this is the, here we can see the longest substring is B, C, D, E, R, F, T, which is having length of 7, right? So this is what we have to achieve, right? So with the help of sliding window technique, we can simply solve the, we can simply solve the problem in a very optimized way. Let us compare this complete logic with sliding window template. Because in the last video I proposed sliding window template, right? For to solve any sliding window problems, we can simply use that sliding window template. So let us see the differences with the with this code and the proposed sliding window template. Okay, so here I started with while j less than input dot length, and if I see in the sliding window template here, the same thing. Sorry. If you see here, so the same thing what we have right in the code. So if we compare, we get the same thing as we have in the code itself here, right? Here we have added the calculation logic. We have to add the calculation logic. This logic can be different, can be vary, right? And then I have added the base condition, third one, the second one, sorry, else if condition. This is the base condition, right? And then I have added these conditions, like if the map size is less than window size. So if condition is less than window size, so there we will remove the ith windows from the map, right? So this is the second conditions. I did not put third condition, this one, because this was not required with the with this logic. So I simply ignored these conditions. I used only these two conditions. So to solve any sliding window problems, we can simply use sliding window template. This is the proposed template. We can simply use. The logic can be vary. There could be a slight variation, but yeah, we can simply use the same sliding window template to solve any sliding window problem. Thank you. Bye bye.